and gentlemen, my name is Dr. John Belkwitz. I'm the Director of R&D at Intelligent Concrete, where we specialize in making concrete do the impossible.
I'm Whitney Belkowitz, President and CEO of Intelligent Concrete.
And I'm David Harris. I'm the Principal Engineer for Intelligent Concrete.
And we're here to talk to you today about the handheld penetrometer.
No, we're not.
Not today.
Not today.
Not today.
No, it is High Range Water Reducer Flower Week.
I love that.
Today, our video is brought to you by...
The red rose, gentleman's favorite.
Gentleman's favorite.
It is a beautiful flower.
It is a beautiful flower. And what we're targeting today for our high range water reducer is we're looking at 3 different types of concrete. And each one of us specializes, and I love saying that, each one of us has their own specialty in concrete. I'm going to be talking about fast track pavements,
Geopolymers.
Mass concrete.
So let me, do you guys,
Yeah,
y'all mind
please.
if I start off? Okay, so our high range water reducers, I only have 2 minutes. So the person who breaks that 2 minutes
Pressure is on.
has to buy pie for the next pie day.
You're wasting a lot of time talking about
I'm
it.
okay, I'm that good. So fast track pavements. I think that there is no other type of water reducer than to use a polycarboxylate based high range water reducer for fast track pavements. There are a few things that I use a high range water reducer for. The first one is, and I call it my lever systems. The first one is to get that initial spread or slump in that slump life at least over 90 minutes. The second thing, and that's the thing that we always use high range water reducers for. But the other thing that we always use high range water reducers for is to get that water to cementitious ratio down, down, down. With my fast track pavements, I want at least as low as a 0.35 water cementitious ratio. I normally don't go below a 0.33, but I definitely don't want to go above a 0.35 or a 0.36. And the final thing that I like to use, and I really think high range water reducers, the polycarboxylate based ones, are the only way to go. The other thing that I use them for is their hydration stabilization or their retardation effects. I have this rubber band theory where I add not only the high range but a hydration stabilizer and accelerator, and I'm holding back those hydration kinetics to get that dormancy window, that plasticity, to get the great concrete in the mold. But I still want that strength to take off like a bat out of hell. Skyrocket in flight, afternoon delight. And that high range water reducer is part of that lever system to get me not only the flow, the water cementitious ratio to get those strengths, but also that rubber band effect. So I hit those strengths at that 4, 5, 6 hour to open up this slab for traffic.
Love it.
So, minute 52.
I see that. All right, so for geopolymers, yes, I would absolutely use it for geopolymers. And I think the biggest reason is strength is such a battle with geopolymers to begin with, just because you're not using any Portland cement. So being able to use other chemicals and other things to help increase your strength, you know, anytime you're pulling out water, you should be increasing your strength. So being able to pull the water back a little bit and put a little bit of high range in is going to get you a lot closer to that strength that you're desiring when you're using a geopolymer. So, yeah.
Why wouldn't you use a naphthalene or a lignin?
Oh, why use a polycarboxylate?
Yeah, why use a polycarboxylate?
Because they are my favorite. No, you know, you're dealing with a lot of different chemicals and everything with the geopolymer concrete. The polycarboxylate works very well with the other things that you have to use. So yeah, the chemistry works out well, and we've got a handful of high range water reducers that we use regularly. We know how they work, we know what they work with, so we've got a lot of confidence in those ones, so we know how it's going to be able to react and get us the desired benefits for a geopolymer concrete.
I would add to that using the older types, the ones that are based off of not steric propulsion but electronegative potential, you might have some negative interactions between those lignins, those naphthalenes, because of that chemistry that you were talking about. Still within 2 minutes.
All right, mass concrete. I'm going to talk about mass concrete as if it's a dam. So sort of the old school last century definition of mass as massive amounts, not just temperature. So for dam concrete, we want strength, so we're going to use a water reducer to help increase the strength. We don't need speed. In fact, we probably want something slower because we want to dissipate the heat as those large blocks of concrete are made. So water reducer, yes, for increasing the strength. We want to adjust it carefully to make sure that we have slow heat dissipation. We need to be very careful about shrinkage. We're going to be making massive, very large blocks. We need to control the temperature and the shrinkage. So yes, on the high range, but it has to be added carefully.
And when you say carefully, do you mean that we can't go too crazy with it and drop the water cementitious ratio down, which will inherently increase heat?
Absolutely. We can't go too crazy. We have to be conservative to make it cool, make it heat slowly or not put up as much heat, control that shrinkage. So we have that. Dam mix designs a little different from normal design.
Dam mix designs sure are different.
Those dam engineers and their dam concrete with their dam mix designs, you know, it's the reality of it.
It is.
Yeah, it's a different kind of concrete.
Do you think it's easier to use the old school water reducers as opposed to the high range or the polycarboxylate base?
I think you can use the modern, the modern solutions, the modern versions. And of course, they're just so much easier to get as well. I mean, and when you're out in the middle of nowhere, I mean, you have to kind of get what you can get.
And you don't get upset.
That's right.
So thanks for joining us today. We hope you learned some. Let us know if you have any questions or concrete concerns. Don't forget to like and subscribe. Go Concrete!
Beat asphalt.
Beat asphalt.